In this video, we want to evaluate the definite integral from 0 to pi over 2 of cosine of x over 1 plus sine of x. So notice that if I take the derivative of the denominator, 1 plus sine of x, I get cosine of x. So that tells us we can use a U-substitution here. So we can use a U-substitution, evaluate the integral, and then apply the limits from 0 to pi over 2 to get the answer. Or we can transform it into an integral involving u, change the limits of integration in terms of u, and that will also work out. So let's start off by selecting u to equal to 1 plus sine of x. Then the derivative of both sides, left side I put du. On the right side, the derivative of 1 is 0. Derivative of sine of x is cosine of x. And that will also give me the dx here. So notice in the numerator I have cosine x dx. So this will equal rather to the integral. And again, in place of the cosine of x dx over here, that's equal to du. So I'm just going to put du here. And the 1 plus sine of x, that will be u. Now I can't use the 0 to pi over 2 here because I have this in terms of u. But if I just leave this as, 1 plus sine of x, then I could do that. But I'm going to go everything in terms of u. So what I'll do here then is say, if limits go x equals 0 to x equals pi over 2. So let's start with x equals 0. When x is equal to 0, from this statement here, the sine of 0 is 0, so u would equal to 1. And then if I go replace the x by pi over 2, when x is equal to pi over 2, plug it back over here, sine of pi over 2, or think of that as 90 degrees, is 1, and 1 is 2. So u would equal to 2. So I just go with these limits in. Instead of x equals 0 here, I have u equal to 1. Instead of x equal pi over 2, I have u equal to 2. And then I just integrate here. Integral of du over u, or you want 1 over u du of absolute u. And then we use the limits of integration from 1 to 2. So then this will be then ln of absolute 2. Well, this will just be 2. You don't need absolute values here. That'll be 2 there. And then minus the value at 1, ln of 1 here. Again, absolute value of 1 is 1, so this will just be 1. And the natural log of 1 here is 0. So this gives me ln of 2. That's the exact answer. You want to approximate, use your calculator. You can write this as 0.693 to 3 places. So exact there, and this is an approximation. Now just to point out the other way I was talking about here to do this, that's the solution, doing it that way. But if you want to use the same limits we started off with here, you could just say the integral of, then this is just going to be ln of u. So replace the u. What do we get for u? For u, if you leave it in terms of u, the original I'm talking about, so 1 plus sine of x. You leave it like that, instead of doing all of this here and just go, okay, I'm going to integrate using the original limits from 0 to pi over 2. And we evaluate at pi over 2 here. So we place the x pi over 2, so the sine of pi over 2 or 90 degrees, that's 1. So 1 and 1 is 2. So that gives me ln of 2. And then it's minus the value at 0. So the sine of 0 here is 0. So that leaves me with 1. But the natural log of 1 is 0. So I get the same thing. And then I can still use the calculator to come up with the final answer of 0.93. Thanks for watching. We'll see you next time.